All right. This is question 6 on test 2, the free response. You're given a graph, and that graph is of the derivative of f. Alrighty then. Question A says, for what value of x in the interval from -4 to 4 inclusively does f have a relative maximum? Justify your answer. All right, just real quick, a quick sketch of that graph looks something like this. It looks like a McDonald's sign. All right, something like that. This is f prime of x. All right. Well, let's see here. Again, this tells me where my slopes of f are positive and negative and where they're 0. Well, if you look at this point right there, I know the slopes are positive to the left of this value. They're negative to the right of that value. We're going to estimate that value to be 3. So I think at x equals 3, you will have a maximum, a relative max. And the reason is f prime changes from positive to negative. Let's put that in parentheses at x equals 3. Part B is just like part A. It wants to know where it's a minimum, so the minimum would occur right there, which is about x equals -3, and it'll be the same reason as before, but in this time f prime will change from negative to positive. Question C asks, hey, where for the what values of x is the graph of f concave down? Use f prime to justify your answer. Well, again, concave down means that the derivative is decreasing, right? And so from here to here, whatever those values are, I think that's 0, it's decreasing, and from here down forever, it's decreasing, correct? So from here to here on the x-axis and from here to here on the x-axis, it'll be concave down. And the way I interpret that is about -2 to 0, a union 2 to 4, with a bracket on the 4, because this is a closed interval. Okay, question D says, if f at 0 is 0, find the value of the definite integral from -a to a of f of x dx and justify your answer. This might just be my favorite problem in this book. All right, so if you take a look at this graph, ladies and gentlemen, this is an even function, correct? So this derivative is an even function. Well, what does that tell me about the original function? Well, take a look at something. My assumption is that original function f of x is an odd function. Now, let's take a look at something. If f of x is odd, then by definition, f at -x has to equal the negative of f of x. Well, if that's the case, if I take the derivative of this equation, wouldn't I get the derivative on the left is the derivative of f prime of -x, but this is composition. I have to multiply by the derivative of the inside, which would be -1, equals the derivative of the right side, which is be negative f prime of x. Well, wait a minute. If I divide this -1 across, wouldn't I get the f prime of -x is equal to f prime of x, which tells me right here, by definition, this is an even function, okay? So what have I just proven? I've proven that if f of x is an odd function, then the derivative will be an even function, right? And so therefore, I know that if this derivative is an even function, the original function must be odd. And therefore, I can assume that the integral from -a to +a of f of x dx must equal 0, because the upper and lower limits are from -a to +a. And there you go.